Hi guys, here we have lesson 11 on formation reactions this week. So formation reactions are when you take some elements from the periodic table and they form a compound. So like if we took hydrogen and oxygen and put them together and they made water, hydrogen and two oxygens. Formation reactions can be called synthesis or composition reactions. All of those words just mean you're forming a compound out of elements on the periodic table. So here we can see that we take an element from the periodic table plus another element and it makes a compound. So writing and balancing reactions takes a lot of steps. This is why we've practiced writing ionic compounds for so long, because usually we start with the words. And the first thing we have to do is take the words and write the chemical formulas. So the first example has sulfur burning in air, making sulfur dioxide. So the first thing we need to know is sulfur and air, or by that they mean oxygen, are elements off the periodic table. You just write the elements formula from the periodic table unless you see it in that little box of polyatomic elements. So here's the periodic table. And here's that little box that I'm talking about. Polyatomic elements: astatine, bromine, chlorine, fluorine, hydrogen, iodine, nitrogen, oxygen, phosphorus, and sulfur. If you have any of those elements, you always write them with the numbers that you see in this little box. So we have sulfur, we're going to write S8, and we have oxygen, which is O2. So remember, we talked about these elements only. Basically, they always come with a buddy. So oxygen always comes with a buddy. There's always two oxygens together. Sulfur, there's always 8 sulfurs if it's by itself. This is nothing to do with writing it as a compound. When you write sulfur with something else, the 8 doesn't matter. Okay, so you're going to write S8 for sulfur as an element, and you're going to write O2 for oxygen as an element. Now I want you to find those on the periodic table again and decide what state they are. So I see oxygen has a little gray background on the periodic table and sulfur has a white background. So if I go to this page, there's a legend at the top that says white backgrounds are solid and gray backgrounds are gas. So that's what I'm going to write for the elements here. It looks like sulfur is found as a solid and oxygen is found as a gas. Sometimes if you read the sentence, they might even tell you in words what it is. Now in equations here where we would put our equal sign, so what we're making, we put an arrow. That's the chemistry equivalent of an equal sign. Now, sulfur dioxide, I'm going to write for you. Lots of you are using prefixes like the di that we have here in your ionic compounds. We skipped over the lesson because of COVID on molecular compounds where you use these prefixes. So anything that has these prefixes, you guys won't know how to do. Okay, when you're writing your ionic compounds, you guys will never need to write a prefix because I haven't taught you that. So yes, there's some questions in the practice booklet that you're not going to be able to do because they have these prefixes. So I'll write this for you like that. And this, I'm just going to tell you, is a gas. So now we've got what's called the skeletal equation. We've got all the chemical formulas written properly. We've got a plus sign where we're combining sulfur and oxygen, and we've got an equal sign where it says we make something else. So this is telling us if I go in the lab right now, I grab some sulfur and some oxygen and put them together, I can make sulfur dioxide. Now, the law of conservation of mass we talked about last week, and that tells us that if we start with a certain number of sulfur, we have to end with the same amount of sulfur. Sulfur can't just disappear in thin air, and we can't just make more. So for this example, we're starting with 8 sulfur atoms, okay? When we look at our equal sign, there has to be 8 on this side and 8 on this side, okay? It has to balance. So what I have to do is I have to force there to be 8 sulfur elements on the product side, or SO2, and the way that I do that is by putting an 8 in front of SO2. Okay, but that 8 multiplies by the sulfur and it multiplies by the oxygen. So where we had 2 oxygen to start with, we now have 2 times 8, or 16 oxygen. Let's just put that in brackets so it doesn't look like a 0. Okay, if we now have 16 oxygen on this side, I'd like you to make 16 oxygen on the reactant side. We already have 2. What do I need to put in front of O2 so that it multiplies to make 16? 8 times 2 is 16. This is now a completely balanced chemical reaction, and that's what we're looking at doing in our next 5 lessons. Let's practice this some more with the next one. Hydrogen and nitrogen form ammonia, or NH3. All right, hydrogen and nitrogen. We just saw those on the periodic table under the polyatomic elements. Here they are. Hydrogen is always with a buddy H2, so is nitrogen. Hydrogen has on the periodic table a gray background, so that represents gas, and so does nitrogen. So this is going to look like H2 gas plus N2 gas. A little hint when you're writing these, leave a little space, because remember we might need to put numbers in front. These are forming, so that's where your equal sign goes, ammonia, or NH3. Now, ammonia is in our periodic table booklet somewhere. I'm going to go to page, let's see, what page has my list of compounds? This one right here. This is page 5. This one has ammonia on it, and I'm looking it up because I didn't know what the state was. And I can see the very first line on page 5 says ammonia is NH3 gas. So I'm now going to add that to my equation. So you can see that you need the correct chemical formula and you need the states for all of this. Once you have those written properly, and it's worth it to slow down and make sure these are proper, because if you don't write them correctly, then you'll never be able to balance them. Okay, we've got these written properly. So now the way I'm going to balance this is I'm going to look for the biggest number. I see 3 hydrogens and 2 hydrogens. This is where math comes in. How are we going to balance 3 and 2? I can't just multiply by one number that'll make those even. So I need to use the lowest common multiple. We used this for writing chemical compounds earlier. What's the lowest common multiple of 2 and 3? That's going to be 6. So I'm going to try and make 6 on each side. So on this side, the left, I'm going to multiply 2 by 3 to make 6 hydrogen. On this side, the right, I'm going to multiply 3 by 2 to make 6 hydrogen. Now the hydrogens are balanced. Let's go ahead and look at what we just changed on this side. 6 hydrogens, but also 2 nitrogens. That's exactly what I wanted. I have 2 nitrogens on the product side and 2 nitrogens on the reactant side. This is completely balanced. What number do you think you might put in front of the nitrogen if we don't need any number at all? What you can put is not a 0, but a 1. You can put a 1 in front, and then we've still got 2 nitrogens, and you know that you're finished balancing. Question 3. Magnesium and carbon and oxygen form magnesium carbonate. Here we have 3 reactants: magnesium, carbon, oxygen. Are any of those in the little box on the periodic table? Only one is. Oxygen is O2. Everything else is just going to be its chemical formula. So magnesium is just magnesium. We don't put a number behind it. Here's a common mistake students make. We've been working a lot with the charges. Lots of students will put a 2 behind magnesium because it has a charge of 2 plus. But the only things that get numbers behind them are the few elements listed in that small box on the periodic table. Since magnesium is not there, magnesium does not get a number after it. I'm going to look on my periodic table now for what state magnesium should be. It's in a white box, so that represents solid. Leave a little space, and then we can do carbon. I just checked, and it's also in a white box, so solid. It's also not in the polyatomic element box, so there's only one carbon. Here's my oxygen from the polyatomic element box that always comes in a group of 2, and we've used this before, so I know it's a gas. All 3 of these are being put together in a lab, and what's coming out is magnesium carbonate. We've been naming ionic compounds for a long time now, so when you see this name, you should know, yep, that's an ionic compound. I need to balance the charges. So I'm going to put the charge of magnesium, and I'm going to look up the charge of carbonate because I don't remember. Carbonate has a different ending. It's not IDE. So if it's not IDE, it's probably polyatomic, like we have in this box on the periodic table. I found carbonate in the first column, CO3 with a charge of 2 minus. I'm going to write the charge above carbonate. The 2's cancel out, and you simply write magnesium carbonate. Now I need to decide what state it is. This is why we've taught you the solubility table. Back to the data booklet we go, looking for the solubility table now, and here it is. We need to find on the top either magnesium or carbonate. I see partway through maybe the middle column, I see CO3 2 minus. That is carbonate. I'm going to go below carbonate and read that in the aqueous row, group 1 ions and NH4 form aqueous solutions. Most other elements are going to form solids, or what we call a precipitate. So this one is not a group 1 ion. Magnesium is not NH4, so magnesium falls into the most box. If you go over to the left, the most box has a solid symbol. So magnesium carbonate in the lab would form a solid under most circumstances. There's our skeletal equation. Now we have to balance it. Look for the biggest number. 3 oxygens is the biggest number I see. On the reactant side, I have 2 oxygens. On the product side, I have 3. The number that's going to balance that is 6. 2 times 3 is 6. 3 times 2 is 6 oxygen. The next thing I go to is everything that just got changed by putting this 2 out in front. So I've just made 2 carbons and 2 magnesiums. What I'm doing is I'm multiplying by the secret 1's that are behind. We would never write those, but just for learning it, I'm showing you the ones. So 2 times 1 means 2 carbons here and 2 magnesium. I'm going to try and make 2 carbons over here and 2 magnesiums. These both have secret ones as well, so that means I just have to put a 2 in front of those ones to balance it out. How might we ask you this on a test? We might give it to you as numerical response. Remember those boxes? And then you would put the numbers in the order that you see them in the boxes like that. Example 4. Sodium plus silicon plus oxygen makes sodium silicate. The only element I see here that's on the polyatomic element box is oxygen. So sodium is just going to be Na, silicon is going to be Si, and oxygen is going to be O2. So I've written them down for now. I'm going to check what those states are in my periodic table book now. I see silicon with a white background, and I see, what was our other one? Sodium on this page, also with a white background. Those are both solids. They make sodium silicate. As soon as I see that's an ionic compound, I need to write the charges. The charge for sodium looks to me like it is +1. The charge for silicate in this polyatomic ion box over here, about 3 columns over, is SiO3, 2 negative. Those are the charges I just determined. How are we going to manage those charges? We are going to cross them. So there is going to be a 2 behind sodium, and behind silicate, a secret 1. We don't put the 1 and we don't need brackets because it's a 1. Now to determine the state, I'm going to my solubility table, and I'm looking to see if I can find on the top row silicate, SiO3, or sodium. Now sodium is a group 1 ion. I don't see silicate anywhere, but I do see sodium in the first column. It's in the group 1 ions. So I'm going to go below. It's either going to fall into the solid or the aqueous rows, and I don't see sodium silicate listed under the solids. So that means it falls into most, and this will be an aqueous solution. There's our skeletal equation written properly. Now let's balance. Again, the biggest number I see is 3 oxygens and 2 oxygens. How does that balance? 3 times 2 is 6. 2 times 3 is 6. Our oxygens are now balanced. Now here I have 2 times 2 is 4 sodium. On the reactant side, I'm going to write 4 sodium. Remember, there's a secret 1 behind silicon here. So 2 times 1 is 2 silicon. I'm going to write 2 silicon. And that question is done. 5 and 6, if you read through those, they haven't given you the answer. They've said magnesium plus fluorine make blank. You have to determine what those would make. So if I took magnesium and fluorine and put them together, this is what you've been doing all along in chemistry. You've been making an ionic compound called magnesium fluoride. The first step is to just write it in words. Once we have it in words, then we can determine the charges and cross them so that we can write the ionic compound properly. We've already done magnesium today, so I know it's Mg solid. Fluorine, I'm going to check because it could be a polyatomic element in that little box, and I do see fluorine in there. It's F2. The state of fluorine, I see in the box, the background is gray, so that's a gas. So I'm going to write F2 gas. Leave a little space so that you can put the number in front when we get there. They make magnesium fluoride. Look up the charges on your periodic table for magnesium and fluoride. Fluoride is -1. Magnesium is +2. And cross the charges. MgF2. Don't stop here because you need to know if this is solid or aqueous. Here's my ionic compounds. Do I have magnesium or fluoride on the top? In the second column, I see fluoride, F negative. If I look below, do you see magnesium listed below fluoride? Yes, you should see magnesium listed right here, Mg2+. So you go over and you see that it has to be a solid. Now we want to go ahead and balance. The biggest number that I see is 2 fluorine, 2 fluorine. Those are already balanced. Remember that we're checking on either side of the equal sign. Then I see 1 magnesium, secret 1 behind it, and 1 magnesium. If this is completely balanced and you want to show me that it is, you just put 1s in front. Then you're done. So pause the video and see if you can figure out what silver and oxygen would make in the next question. Silver plus oxygen is going to make silver oxide. Writing the metal first, the non-metal second, and changing the ending to IDE. Silver is not in the polyatomic element box, so I'm just going to write silver as Ag, solid. Oxygen we've worked with many times today. And silver oxide, I'm going to need to know the charges. So looking for silver on my periodic table, I find it has a charge of +1. Oxygen has a charge of -2. Writing the charges and crossing them. Here we have silver oxide. We can now go to our data booklet, find our solubility table, and look in the top row for either silver or oxide. If you can't find either silver or oxide, that's correct. It isn't listed on this table. And all you're doing is you're looking at this top row. That's the only thing you're looking at. If neither one is there, you always default to solid. So if you can't find them on the periodic table, solubility chart, you put solid. Now let's balance. They both have 2s, so it doesn't really matter where you start here. Let's start with this oxygen. I see 2 and 1. I need to double the oxygen on this side so they balance. I now see 4, 2 times 2 is 4, silver. 4 silver. This is balanced. I can put a secret 1 in front of the oxygen, and I'm all done. It might be worth it for you to go through at the very end and make sure that you have 4 silver, 2 oxygen, 2 oxygen. Make sure that everything is balanced, and when it is, you're done. Now, if we had started with the silver, we might have only put a 2 on this side. This is why we always do these in pencil. Sometimes it's trial and error, and you would see that the 2 wasn't big enough to make the oxygens balance. If that's the case, you erase the 2 and you try a 4, the next biggest number. For this section, you have questions in your practice booklet and the answer key posted. Let me know if you need any help, just email me.